Okay, to start today, I want you to try this puzzle. So the letters in each row add up to the numbers next to them. So for example, T plus V plus T plus U is equal to 12. Same goes for the columns. So we've got we've got 2 rows and 2 columns with 4 letters in total. The letters are actually all represent numbers. Can you work out what these are and hence add up this row here? Have a go. Okay, to do this, I would start with this row here because I've only got a single letter going on. So it's going to be 4s is 16, and therefore s is 4. And I found my first one. I can replace it here because now I can look up this column, and then I've got 3u plus 4 is equal to 19. So 3u is equal to 15 and u is equal to 5. Okay, so brilliant. I can also look up this column, replace my s by 4, and I've got that 3v plus 4 is equal to 13. Therefore 3v is equal to 9 and v is equal to 3. Okay, I've got one more. I've not yet dealt with this row here. I can replace my v by 3. I can replace my u by 5. And then I've got that 2t plus 8 is equal to 12. That means 2t is 4 and t is equal to 2. And I've got all my values, so I can now say instead of s, I've got 4, instead of v, I've got 3, instead of t, I've got 2, instead of u, I've got 5. If I add these up, 7, 8, 9, the answer we were looking for is 14. Well done if you got that. So actually, this was an example of simultaneous equations because I had 4 equations and 4 things I didn't know what they were, and that's what we mean by simultaneous equations. We're not going to, this one worked out all right because some of the equations were particularly simple. One of them was 4s equals 16. In theory, you could have 4 equations that all contain s's, t's, v's, and u's, and that would be really tough to solve. It's possible, but really tough, whereas this was a slightly nicer version, although it still involved quite a lot of calculating. We are going to look at just 2 equations with 2 unknowns, and there's lots to study here. Before we do that, we're going to take a look back at y equals mx plus c. So can you use that, that's a big hint that I've just given you, to plot these 2 graphs? So you will have had to have got some graph paper and drawn the axes and everything to be able to do this. But if we just go through it then, so we've got to remember that basically the thing in front, the x, is my gradient, and then the thing by itself is my c. So for this one here, I know it goes through 1, and then I know the gradient is 2, so for every one I go along, I go up 2, okay, because that represents 2 divided by 1. If I go along 1 again, I go up 2, go along 1, go up 2, and that gives me enough points to be able to draw my line. Okay, so I know it's going to go through there, go something like, that did not work, it's meant to be a straight line. Better. Okay, so that is my first graph. I'm just going to label it y equals 2x plus 1. Second one is going to be very similar. This time c is minus 1. But I've got a steeper gradient, 3, which is 3 divided by 1. Rise over run, that means I go along 1. For every 3 I go up. Along 1. For every 3 I go up. Along 1. For every 3 I go up. What I'm seeing is that it's sort of, like they're crossing. Okay, so let's finish this off. Okay, brilliant. So we've drawn the graphs. Where do they cross? They cross at 2, 5, this point here. And just bringing it all together now, I said at the start, we're trying to solve simultaneous equations where I have 2 equations and 2 unknowns. And actually that is exactly what I've got here. It's just in a slightly different form. I've got 2 equations and they represent lines, and I've got 2 unknowns, and we've just solved when like they cross basically when they both when they both work essentially. So because if I put in x equals 0 and y and I'd get out -1, I wouldn't get the same here. But for this single point, I get this. If I put in the value of 2 into the right hand side, I get the value of 5 out. Now that is a graphical approach to solving simultaneous equations. We are going to look at an algebraic approach. So we're trying to basically solve this and this, but they are simultaneous because I got 2 things that I don't know, which is different from when I solve equations like x plus 2 equals 7. Here I've just got 1 thing I don't know. So I can't just take one of them and do anything with it. I've got to take both of them. So this is what I do. I want to find where they're sort of where they have the same values as such. So when I put in x, I get the same y. But that is the key to it, because they're going to have the same value of y. So if these are the same, I can actually write down that the right hand sides are the same. 2x plus 1 must equal 3x minus 1. This is my first step. Step 1. I hope that makes sense. I've just set them equal to one another because I'm interested in where the y values are the same. And then I've got an equation involving just one of the unknowns, and I'm happy. So I would minus 2x from both sides to give me 1 equals x minus 1. I would add 1 to both sides, and that would give me x equals 2, which agrees with the graphical solution. It has to. So I'm contrasting a graphical solution of simultaneous equations with an algebraic method. The algebraic method is going to be much more powerful because I don't need to draw a graph to get there. What do I then do? Step 2. Okay, substitute. I know that x is equal to 2 in the case where the x values and the y values are the same. So I can substitute my x value in to find out the value of y. So I'm going to put it in the top one. It's going to be that y is equal to 2 times 2 plus 1, which is 5, which agrees with this one. Not coincidentally, it must. So I've chosen to put it back into the first one. You might be saying why into the first one, but it doesn't matter. If I put it into the second one, it will be 3 times 2, which is 6. I would minus 1, and I would get 5. That would be a way of double checking actually my answer. So basically, if I say solve the simultaneous equations, but I'm not going to write that down, solve y equals 2x plus 1, y equals 3x minus 1, I could use this graphical method, but what I want us to be doing is using this algebraic method, and my solution would then be x equals 2, y equals 5, and I'd be done. So example 2, I'm going straight into it. I'm giving us 2 simultaneous equations I want us to solve them. How are we going to do this? Well, before I had y on the left-hand side of both equations and I set them equal, but I don't have that here. So I'm going to need to make an extra step. I'm going to keep the first one as y equals x plus 2, but I'm going to rearrange this second one to make y the subject. So I'm going to minus x from both sides. It's going to become y equals 6 minus x. I've now got it in a much nicer form. And now I can set them equal, set the y values equal. So I'm going to get x plus 2 equals 6 minus x. I've got a minus x here, so I'm going to add x to both sides. 2x plus 2 equals 6. I'm going to minus 2 from both sides. 2x equals 4 and x equals 2. Okay, I then sub back in. And I'm going to choose to sub it back into that top one. So I'm going to get y equals 2 plus 2 because I've replaced this x by the solution 2, and then I get 4. To be extra careful, I'm just going to double check. When I put 2 in and 4 in, I get 6. I know I must be correct. I couldn't have fluked that. So that is my solution. X equals 2 and y equals 4. Let's just double check. Not double check, but talk about the graphical solution instead. So in this case, I could plot y equals x plus 2. So I know it's going to go through 2, and then I go along 1, up 1, along 1, up 1, and so on. That's going to give me a straight line like this. Okay, that is y equals x plus 2. And then to plot this one, I'm going to rearrange it. I'm going to use this one here, 6 minus x, which we could write as minus x plus 6. That gives me an intercept of 6, and it gives me a gradient of minus 1. So that means I go along 1, down 1, along 1, down 1. And then I can again draw my straight line. Okay, and look where they cross. They cross at x equals 2, x equals 4. So I just want to emphasize, like, I don't need to do both methods. And you know, the algebraic method is quicker. You might be asked to solve it graphically, but I just wanted to illustrate both. But actually, this thing on the right-hand side is all you need to solve these simultaneous equations, and that's what I want you to be able to do. I really want you to have this understanding that we're not just solving equations here, we're actually finding out where two straight lines cross. They are one and the same thing. Again, I'm linking algebra to geometry. So just to recap, simultaneous equations are equations where you have more than one unknown and you're trying to find it. You're trying to find the sort of the combination that works for everything. So, you know, this y equals 2x plus 1, it goes up this black line here, but there's only a single point where the y and x values work for both equations, basically, and that's my solution to the simultaneous equation. We can solve them graphically, but we've got this method for solving them algebraically, setting the y values equal. We are actually going to be looking at more sophisticated techniques coming up, but I'm going to leave that for now. Every single time we're going to try and set the y values equal. So hopefully that makes sense. I'm going to get you to practice some questions now. Well done.